Welcome everyone to Rocks for Jocks. For a few semesters in college, I tutored varsity athletes in earth sciences. Students were required to take 2 science courses in order to graduate in any major, which meant a number of students piled into what they thought were easy courses in the earth sciences. These were commonly referred to as Rocks for Jocks courses, which is partially where the name for this podcast came from. I thought it could be fun for a couple of episodes here to dive into some of the topics I used to tutor in those classes. One of the problems I touched on frequently, which people struggled with breaking into digestible pieces, was climate change. The first thing we need to define here is the word climate, which is generally known as the long-term weather patterns of an area. In this context, we are talking about global climate, which itself can be broken into temperature, precipitation, wind, and a few other factors. These are normally different in different parts of the world, but we can still group all climate factors of a certain time period together as that period's, quote, global climate. The second thing we want to consider is the word change. While our global climate is always changing due to several factors in nature, humans are also having an impact on the global climate. The human impact is what most people in modern times are referring to when they use the phrase climate change. You may also hear this referred to as anthropogenic climate change, which just means human caused. Why does climate change matter? Climate change has a bunch of impacts to our planet and the people living on it. When I was writing out the script for this episode, I found this section especially tricky because it's kind of hard to touch on these without going into a deep level of detail. So I'm going to list a few of them here. I encourage everyone that if you find you're interested in any of these, ask some more questions to Google or even ChatGPT just to get a sense of what else is going on in those topics. So the most direct impact that I would say climate change has on humans is that we have a big increase in climate refugees, which are going to be people fleeing hot countries for cooler countries. There's no single temperature at which this happens, but over time, people flee hotter countries as they get hotter and hotter. Another really big direct impact to humans is that climate change increases the severity of storms. This happens for a couple of reasons, one of them being that hotter temperatures means the atmosphere can hold more water, so that when precipitation events happen, more rain falls out of the sky. And kind of tied into that, the patterns of severe storms change. So if we were to see changes in hurricane patterns, for example, in the US, that could be pretty problematic. People in the northeastern US don't build roofs to sustain high levels of wind and rain. So getting really destructive hurricanes up in the northeast would be much more destructive than they currently are in the south. This also ends up having a pretty big impact on flooding patterns, because we get increased precipitation during these severe storms and happening in places that are not prepared for it. We don't have things like flood walls set up in the Northeast. We don't have enough drainage set up for severe flooding. So that would just cause a lot more damage than flooding currently does. Climate change causes changes in the water cycles around the Earth. That also means we get increased droughts in areas that we don't expect. We only have infrastructure set up to prepare for the current locations of water, especially fresh water. So that could also be really problematic as time goes on. Another pretty big effect of climate change is that it leads to glaciers melting more than they currently are, which in turn leads to sea level rise, which in turn leads to more land covered by water, and contributes to a bunch of other problems, such as also increasing the number of climate refugees when people are displaced from different countries. Even in large, wealthy countries, losing coastal low-lying areas is not really a good idea. This is where most of our populations live and where most of our expensive infrastructure is built. The final impact of climate change that I'm going to talk about today is ecosystem changes. Not every species is going to be able to adapt quickly enough to survive their own climates changing. My understanding is that this will happen slowly, and it will be a little bit hard for the layperson to notice it happening. In the grand scheme of history, species are created and lost all the time. So at first glance, this may not seem like a big deal, but without going into too much detail here, I'll just mention that more species, also known as biodiversity, is generally considered a good thing for everyone and all species involved. For my next section, I'm going to talk about what exactly causes climate change. How are humans doing this? So human-caused climate change is primarily the result of us humans releasing gases into the atmosphere, which changes our long-term weather patterns. The Earth's atmosphere is essentially a layer of gases surrounding the ball of rock we call Earth. It's made up of 99% nitrogen and oxygen and tiny amounts of some other gases. However, even these trace amount of other gases are enough to set other events into motion. About 0.03% of the atmosphere is made up of carbon dioxide, also known as CO2. This is the most common form of greenhouse gases, which have a warming effect on Earth where they trap heat, similar to the effect that greenhouses have on plants. In a really simplified way, I'm going to try to explain the greenhouse gas process here. Number one, energy from the sun comes to Earth as shortwave radiation. Of that energy which hits the Earth's surface, some of it is absorbed by the Earth and later sent back out again into space as long-wave radiation. Number two, greenhouse gases are more transparent to incoming shortwave radiation when compared to how much they trap outgoing long-wave radiation heat. This means that when all other factors stay the same, more greenhouse gases have a net effect of trapping more heat. Without greenhouse gases involved at all, the Earth's global mean temperature would be just under 0 degrees Fahrenheit, compared with the current 59 degrees Fahrenheit. So having some greenhouse gases are important to keep the world's temperatures above freezing. The increase in energy trapped from additional greenhouse gases in our atmosphere is why climate change was for a long time referred to as global warming. The switch was made to climate change because increased heat and energy in our atmosphere doesn't simply raise temperatures everywhere. While it's true that the mean global temperature definitely does increase, it happens unevenly. It raises temperatures in some places, it may even lower temperatures in other places, and it most definitely changes precipitation patterns, wind currents, water currents in all different areas. According to climate.gov, atmospheric carbon dioxide, measured in parts per million, has increased from about 320 to 420 from the years 1960 to 2023, while global mean temperature has increased more than 1 degree Celsius in that same time frame, which is about 1.8 Fahrenheit. 1 degree Celsius may not seem like a lot, but there are a few points to remember which go along with this. Number one is that heat increase is not evenly distributed across the world. In other words, some areas don't change at all, while other areas are going to increase by 2 degrees Celsius, which is 3.6 Fahrenheit. Second thing is that some ecosystems are not going to be affected at all, while other ecosystems do best within a small range of temperatures, So changing those ecosystems within a few years and keeping those temperatures high for the foreseeable future will definitely impact ecosystems, eventually leading to losses in biodiversity, trouble with different food chains, etc. The third thing to mention here is that a few degrees average temperature change sustained over multiple years has a really big impact on glaciers, which, as I mentioned earlier, has an impact on sea levels and sets off other chains of events to continue raising temperatures. This is known as a positive feedback cycle. So, what are greenhouse gases? I've already talked a little bit about the one mentioned most frequently, carbon dioxide. The one that is probably mentioned second most frequently is methane. Greenhouse gases are released through a variety of ways, and the distribution of their release varies by location, time period, culture, economy, technology efficiency, etc. For example, states in the southern United States may use more electricity on a yearly basis due to their air conditioning, but northern states may use more natural gas or oil for heating in the winter times. Some countries may not have access to natural gas at all, so they are using whatever fuel sources are available to help their people survive. With every passing year, human technology is generally getting more efficient and contributing to a slight decrease of greenhouse gas emissions per person. On the other hand, people are also getting wealthier, which generally leads to more emissions per person. Broadly speaking, the biggest contributions of greenhouse gases in our atmosphere are coming from sectors like industry, electricity, heat, transportation, manufacturing, construction, and agriculture. Industry includes things like making cement, chemicals, iron, steel, and plastics. Agriculture is going to be things like corn and wheat and cows in the US. Ultimately, though, changing the amount of emissions us humans release every year is not going to be completely solved by only regulating one sector. But approaches to multiple sectors are going to be needed to reduce greenhouse gas emissions enough to have a positive impact on our climate. Thank you all for listening. Hope you had a good time, learned something fun, learned something new. Take care.